Hello and thank you for subscribing to InfoWars Tech. This is a channel where we explore new trends and technologies, including cloud computing, Python programming, number of other computing languages, artificial intelligence, machine learning, and similar. Today we're going to look at OpenCV, which is a library of programming functions primarily for real-time computer vision. The library is cross-platform and licensed as free and open source software under Apache License 2, and it contains over 2500 algorithms. It's a very powerful library, and as you can see, I have the web page open for it, and you can take a look at the Get Started page, the GitHub documentation. There are very good tutorials there, and excellent free courses available. So I highly encourage you to visit the website and explore on your own. The objective of today's tutorial is to just provide an introduction to OpenCV, show how easy it is to read and write images to the local disk, and also do some transformations in terms of rotating or resizing the image, and perhaps displaying it in a color as well as grayscale and so on. So I will add a link to the other video that I've created, which is very similar to this, except that it uses a Jupyter notebook as the platform, but the code is the same, the one that we're going to demonstrate here. So let's get started, and for this tutorial I'll be using one of my favorite editors, which is a Visual Studio Code, and so let's get started. And so I'm going to start with creating new file, a new Python file, and earlier in preparation for this tutorial I already ran the pip. So in this terminal you would write pip install OpenCV dash Python. So I've already run this command to install OpenCV, and you should do the same. And the version that we're working on is 4.9, and which requires a minimum version numpy of 1.19, and using the pip command the dependency will automatically get installed. So I can go ahead and do import cv2, and the important thing to note here is that although the library name is OpenCV-Python, but when referencing it in our code we use cv2. So an important point to remember. The other thing I'm going to do is then reference that image. So let me just write down the command. So it's going to be img, so just a variable which will get the value when we read that image from our local disk, and the syntax is cv2, so calling cv2 and imread, and let me just copy the location. So in my case it's located here. I'm just going to paste it here, and I just increased the size of the font. Just realized that the font I was using might be too small, so I hope it's legible now. Please do send me a comment, and I can make sure that it's the right font size in future. So let's say I have a quick look at the images folder, and you can see I have bird1, bird2, I have a logo, I have polyglot.png. So I have a mix of JPG and PNG formats, just to show that OpenCV can easily work with both of these formats. So I'm going to point to that users asif images folder, and let's first take a look at bird1.jpg that we saw there, and that's referencing that. The second thing that we want to show is be able to display this. So the command for that is cv2 .im show, and here you can give it like a name, so it doesn't matter. So let me say OpenCV, and I'll show you where this will be displayed. And then we are referencing that variable img. And a couple of commands that we need to add to make this run. And so the first one is cv2.wait key, and with having 0 there, the image will stay there till user presses a key. I can also add 5 or 10 or 15 seconds to wait before closing. And the last one is destroy all windows, so it will then run, then execute that and close that window. Okay, let's run that and see if that works. So let's save it as, let me call it OpenCV demo. I'm just storing it in a location, and that image right here. So image 1, sorry, bird1.jpg. Let's look at another one. So we just change, we know this, we have got another one called bird2. I can just show you again. So that's right there, bird2. When I run that, it brings up that image as well. Let's look at another one. So I have a logo.png, a different file format. Let's run that, and you can see it ran that as well. Infoverse incorporated. And let's look at another one. So I have one called polyglot. When I run that, it displays here as well. And you can see the demo-OpenCV. That's what we put in the IM show. So it's something that you can reference with. Right? Okay, so that ran as well. Now, just want to show that here I can add (1) and rerun that. And actually, you'll see there's no change. It's exactly the same image. So there are 3 ways. One, where you can add 1, or you can add a 0, which will display this in grayscale. So when we run that, now that same image is in grayscale. And the third option is a -1, and that is for opacity and transparency. If your image doesn't have it, you should see the same image basically, right? No change. So those are the 3 versions. If I don't specify anything, then it takes the first one, which is called the cv2.imred_color, which is specifying to load a color image. Any transparency will be neglected, and it is the default flag. And the option is to pass a 1, like we shown earlier. So that's just a quick note on using whether grayscale or showing transparency or opacity, or you just ignoring that characteristic. Okay, let's move on to the next idea here, which is to let's say resize the image. So we saw that polyglot.png was pretty large, so let's make it smaller. So I'm going to create another variable called img2, and we're going to do the same, but except here we're going to say resize. So again, cv2, the library dot resize, and we are referencing the same img, which is this here variable, and then we can specify a new size. So let's say 400 by 400. And so here the important thing is that now that we move the resize to img2, when we are displaying it, this should also be updated to reflect that. So img2 here as well. Now when we run that, we'll see that this is much smaller, or rather it is now reflecting the 400 by 400 that we specified here. Write the syntax for that. So I'm looking at into rotating the image. So image 3, another third variable, cv2 dot rotate, bracket open. I'm referencing the same image, the original image that we read from the local disk, and then cv2 dot rotate, and you can see I have rotate underscore 180 underscore 90 clockwise underscore 90 counterclockwise. So we can make that transformation on the, let's choose this one. So, and again, since this is the new variable, I need to update this here and call it 3, and let's run that, and you can see that it has, it's inverted now. So let's use a smaller and maybe you'll get a better idea. So I have another smaller called VMware, and let's run that. First let me show you how it looks, and then we can, so let me show you how it looks. And here is the image. Now let's run that again and flip that. So I'm going to do 3. I'm going to this one, and let's run that, and you can see this time it's flipped by 180 degrees. So just completely inverted, and like we saw, there were other options we could use as well. Now let's look at the last one, which is writing the image to local disk. So here the use case is that, let's say as this example, we did some transformation to an image. Now we want to save that image as it is, like inverted. So let's do that. Let's see how we can do that. So the command to do that is I'm going to do cv2 dot imwrite, and here you have to specify the location. So in my case, I'm using the same location where I am reading it from. So let me just enter it here. Make sure to get those apostrophes, and here I can call it let's say polyglot inverted, right? Just a name, it could be anything, and make sure to specify the file format, and then you need to refer to the image that you're changing it to. So let's see img here, and let's change that to polyglot. Let's see if that works. So we're reading polyglot.png from the hard disk, and then we are doing a rotation. We're rotating it by 180 degrees, and then here, oh sorry, we need to write the new image, remember? So we in img in line 4 we rotate the image by 180 degrees, and then we save it into a variable called img3, and when we are writing that, we want to write that image that was rotated, right? So let's do a quick check. Looks okay. Let's run that, and okay, so it's displaying here as well as it should have. So as you can see, in that local directory that we specified, it's let me close this and show you that it's successfully written that image on the local disk, right? And it's completely inverted. So that was a quick tutorial to get you interested in OpenCV. It's a fantastic library. It's available in it's cross-platform, so available in different operating systems. So I hope this was interesting, and I will be sure to make a link to my similar tutorial, but that was done on Jupyter Notebook, and I will be following up with a little more detail and more involved tutorials on using OpenCV, which include recognition, perhaps face recognition, and similar use cases. So stay tuned, and if you haven't subscribed already, please go ahead. It helps support the channel, and thank you very much for watching.